All right, continuing on with the same game. If the leading coefficient is 1, the list of possible rational zeros can increase a lot. It's a lot more work. But that's okay. A little hard work never hurt anybody. So we want to find all the rational zeros of this function. So we're going to list the possible zeros, we're going to guess and check to get one that works, and then we're going to use synthetic division. Just so that you're for planning ahead, you see number 5 on your notes. We are not going to do number 5, so feel free to use all the space that you have there. Okay, so we are going to look first at the possible rational zeros. So we take our constant term and we list all of the possible factors. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus, does 4 work? No. 5 does. 6 does. 10, 15, and 30. Okay, I think I got all of those. Divided by all the factors of 2. The factors of 2 are 1 and 2. Plus or minus 1, plus or minus 2. What we have to do is we have to take every number in the numerator and divide it by every number in the denominator. Okay, so let's start with plus or minus 1, our first denominator. So if you take all of these numbers in the numerator and divide them by plus or minus 1, you're just going to get the same thing back. So we can kind of ignore 1 still. Now, we need to think about dividing these by 2. If you take 1 divided by 2, you get 1/2. So that's another one we have to consider. 2 divided by 2, that's 1. We already have that. 3 divided by 2 is 3/2. I have to add that to my list. 5 divided by 2 is 5/2. 6 divided by 2 is 3. We already have that number. 10 divided by 2 is 5. We already have it. 15 divided by 2, we need to add that one. And finally, I don't know why that negative just doesn't want to go. There it is. 30 divided by 2, which is 15. So once we divided everything by 2, we got 4 additional possible zeros. So we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Positive, negative. We have 24 possible rational zeros that we have to try. So what we have to do is just start guessing and checking to see if one of them will work. Honestly, I don't want to write down that much stuff. So like first, let's plug in 1. Okay, I'm picking up my calculator to do this. So I'm plugging in 1, 2 minus 9 minus 18 plus 71 minus 30. I got 16. That did not work. Okay, I'm going to plug in negative 1 now. So 2 plus 9 minus 18. All right, I plugged in negative 1. I got negative 108. That didn't work. Let's try plugging in 2. 2 times 2 to the 4th minus 9 times 2 to the 3rd minus 18 times 2 squared minus 30. Oh, that one worked. Fantastic. Okay, so 2 worked. I'm going to do synthetic division on that so we can get a depressed polynomial. So 2, negative 9, negative 18, 71, and negative 30. And remember, I just did guess and check to find this. Okay, so 2, 4, negative 5, negative 10, negative 28, negative, it's so hard in my head, 56. Is that 15? Let's hope so. 30 and 0. Fantastic. So we've got a depressed polynomial, but this is still going to be a cubic, and I don't think we can do anything with that. So we're going to keep guessing and checking until we find another one. Now, I will give you a hint. I have already done this problem, and negative 3 works. So negative 3 is another 0. So we can do synthetic division. And remember, I just found negative 3 by I just kept going. I plugged in negative 2. It didn't work. I plugged in 3. It didn't work. But negative 3 did. Okay, so we get negative 6, 33, 5, and 15. Okay, now I have a polynomial that I might actually be able to factor. Okay, so if you want to keep guessing and checking, you absolutely can, or you could stop at this point and say, this is 2x squared minus 11x plus 5, and I'm just going to factor that, hoping that it can be factored. So factors of 10 that add to 11 are going to be 10 and 1. They're both negative. Divide this one by 2. So we get x minus 5, 2x minus 1. Remember your other factors from over here was x minus 2 and x plus 3. So here's all of your factors. What were they asking us for? They were asking us for zeros. So our zeros are 2, 5, 1/2, and negative 3. This was to the 4th power, and we have found all 4 zeros.